Okay. Okay. Good boy.
All right, let's go ahead and jump in here and get started because we're running late and we got stuff to do. How y'all doing out there, real world? I am. Well, what we're going to do tonight is we're participating in the Charlotte Game Developers Game Jam, and we're going to essentially learn Godot at the same time. So, and we're going to hard lock ourselves to 48 non-consecutive hours. So, tonight, what I'm trying to do, specifically tonight, is just learn Godot. Like, I'm probably going to try to just go through some tutorials, and then I'm going to try to put together kind of a game doc real quick about what I want to do. And so it's pretty straightforward from there. I don't want to spend too much time on it tonight. I'm trying to limit that to 2 hours so I can spend the rest of the time actually working on the game. Also, we'll be might be working with a team as well off stream. But sit back, relax, and chill. Let's do it. Let's actually start the clock. See how we start the clock. All right, hold on. Oh, the start is right there. All right. So let's bring up this tutorial. Let's get started. Okay, we set up our project. See, in general, see, this game is designed for portrait mode. Click project and project settings. per tutorial, we'll turn it down to 480 and 720. All right, under stretch, we want to set the mode to canvas items. Canvas items base size with the base size specified with height stretch to cover the whole screen. Means everything is rendered directly at the target resolution. Correspondence between cells, which may scaling artifacts recommended most games. Okay. So for the game jam, there is a specific set of tiles that we're supposed to be using. These crawl tiles here in these dungeon tiles. There's a lot of them. So we've got a bunch of assets we can use. Okay, for this, we'll make 3 scenes: player, mob, HUD, which will combine the game's main, which we will combine into the game's main scene. Okay. Skrill Duck 41, how's it going, man? What you up to tonight? Me, I'm doing this 48-hour game jam, and I'm trying to do a Godot tutorial in an hour. We'll see how that works. But how are you doing? So we created our 2D area, and see, this node has no shape, so it cannot collide or interact with other objects. Okay, so just the one that we can't do anything with it. Oh, you're gonna start working on your steampunk world. Okay, is that gonna be a 2D, 3D game? What's your engine? Okay. With the 2D, with the Area 2D, we can detect objects that overlap or run into the player. Change the node's name to player and double click on it. So we add any children to the player mode node. Oh, 3D. Okay. Oh, Unreal Engine. I don't know why it took me a second to pop into my head. Man, I know some people that are really doing some really interesting things just using the blueprint. They're not even coding, so I know how powerful that engine is. Okay. Next time. We want to make sure we don't accidentally move or resize them by clicking on them. So select a node and then click the egg icon to the right of its lock. The tooltip says make select a node, not make selected child's make selected child. Make those children not selectable. Okay. Yo, yeah, I mean, I know you can mix code and blueprint. I definitely know that, but I know people who don't code and are using blueprint and are doing some very interesting things. Click on the icon to the right of the, oh, here, okay. Well, it's like a, got it. There we go, okay. Don't tell me about your game, Skrill, man. Because I do play, you know, my community members' games over here. Okay, and of course save. We're gonna save. It's great call there. Click on the player node and add a Control A. And we're going to add a animated sprite 2D. We're just checking out the stuff over here. Huh, okay. Interesting, interesting. All right. An animated sprite 2D requires a sprite frames resource, which is a list of animations it can display. To create one, find the sprite frames. Under the animation tab. All right, and new sprite frames. And open, click again to open the sprite frames panel. Oh. On the left is a list of animations. Click the default one and rename it to Walt. Well, I'll grab, should have some in here. I didn't pull down the assets for the tutorial. I feel like these are not going to be. Oh, I get it. It is single sprites that change depending on kind of like mode. So I can have gate open, gate close. Okay, I can have these in there and I can change them depending on what mode I want them in. Oh, okay, no, this is, okay, that's not right. I need one. I need like maybe a single. Let's see, can I find? It doesn't matter, I can just use anything to get the point across. Four gateways, shop statues, traps, trees. Player. Oh, this is like different pieces of the character. Hmm. Full metal and half metal world? Okay. Kind of like it's not completely steampunk. It's essentially like what was it? This the world in, they made two games. I can't, my brain is like melting right now. I can't remember. I can't remember the name of the game. It's this something with the character Corvo, and he had like the princess got kidnapped. I can't remember the name right now, but essentially it was like kind of like whale punk. They were like using. It wasn't a steampunk, but it was like a version of it where they were using like whale oil or something. Anyway, again, it's not full. It's not a full steampunk world. And see, these don't have different versions of the same character. I was hoping that this thing would, but we can just use this as different versions, like a left, right, and center of the same. All right, cool, cool. All right. So I know what it's essentially doing here. Essentially, we would rename, oh, we would designate one as the walk animation, one as the turn animation, whatever. So let's take these out because I think it's going like this. So this is, name this like front. And then where's the other one? Yeah, I was kind of hoping there would be different perspectives in here. Can use a null instead. Do that. And we'll just say this is the front. I'm guessing. Say this is left. Oh, what am I doing? And this one would kind of be the up. And so we'll just have like static animations of these different guys. And you would, of course, play the animation through here. Okay. So the player images are a bit too large for the game window, so the default ones that would be part of this tutorial. Click on, let's see, click on the animated sprite 2D node and set scale property to 0.5. What happens if we scale this up? Probably going to be a super pixelated. Yep. Let's just do something so it isn't terrible to look at. There we go. I think so far this has been pretty intuitive. Working in Godot. Finally, add a collision 2D shape as a child of the player. This determines the hitbox or the bounds of its collision area for this character. Oh, for the sprite that would come with this tutorial, a capsule shaped 2D node gives the best fit. So next to the shape in the inspector, new capsule. Okay, we'll do. Let's see. I mean, it is, but anyway. Okay, oh, we have to give it a shape. We'll give it a rectangle. Can I alter? Yeah. Can I do the individual points, or no, it's going to scale all together? Okay. So we get our hitbox. Okay, we'll save. Lesson, add player movement animation set to detect collisions. Do so, add some functionality that we can't get from the built-in node. We'll have to add a script. Click player node and do attach script. Oh, you can actually write the code in Godot. I've seen it before. I've watched actually some Godot streamers, so I actually seen them do it. I just didn't realize they were doing it in the actual engine. Very cool, very cool. Probably take some getting used to, because I would want all my scripts to be in the same place, but I guess they would be attached to the individual nodes. There's probably an easy way to find them or something like that. Anyway. Okay, we'll start by declaring member variables. We're going to give one for export, which allows it to be set in the inspector. All right, so set variables how fast it moves and the screen size. So click player node and we should see those values. Oh, I'm about to say that. Yeah, there it is. Okay, cool. Okay, so we're going to look at the ready and the process, right? Right. I like that it passes you the elapsed time there. Elapsed frame time. Okay, ready is called when a node enters this scene tree, which is a good time to find the size of the game window. Okay, so we'll go ahead and get that value. Let's see, we got the built-in functions here. Now we can use the process function to define what the player will do. Process is called every frame. So we'll use it to update elements in our game, which we expect to change often. For the player, we need to do the following. Check the input, move to a given position, play the appropriate animation. And of course, it's just like start and update in Unity. First, we need to check for input. So the player pressing a key. For this game, we have a four direction inputs to check. Input actions are defined in the project settings under input mapping. Here you can define custom events and assign different keys, mouse events, and other inputs to them. For this game, we will map the arrow keys to the four directions. So let's go to project and project settings. To open the project settings and click input map. All right. Type move right. I guess that's just a built-in function to map. Click add. Okay, then we're going to assign key. Okay, that's going to be the name of the function, I'm guessing. And we're going to assign the key. Ah. I kind of like how how it takes care of certain things where you don't have to actually but in Unity you actually you just in the code telling it what to do per frame. Where here, you just set it up basically to call the specific function when the input happens. Huh. Just, I guess, different flavors of the same thing. Anyway. Let's go keyboard, yep. Okay, we're gonna do that for each one of our oops, wrong way. All right, we got those mapped. Oh, you can also do kind of like the same way Unity does it too, just by like an input object. Oh, okay, I get it now. Essentially, those were triggers I set up. So essentially, the trigger gets called whenever that input happens. But I still have to check if that trigger has been triggered. So let's write some code here. Good old vector 0. And of course, it already has it registered. You know, and after all the issues I've had with the VS Code IntelliJ AI, this feels so much better to deal with. Oh, a bunch of gobbledygook keeps popping up on the screen like it's actually helping me. This actually is helping me. So I just keep. Wait a minute, so you're saying Full Metal World costs way too much room? Is that an actual, like, are you building this in something, some other game or something? Because when you said like Full Metal World or Half Metal, metal. So if, like, you're talking about metal buildings, metal such like. I mean, being that you're building it in Unity, not Unity, Unreal, I'm not sure how that would affect costs. If you're building a virtual world that's all metal, I can see, like, if you're doing a bunch of reflections, like that would definitely be a resource drain. So this is how we address objects in our hierarchy, I'm guessing, with the dollar sign. I don't see play in there, but it says that's a thing. Okay, we'll start by setting the velocity to 0, 0 by there's no real. You're talking about reflections? You're talking, that's the thing, the metal reflection I tried to turn off, but there's no real reflection to turn off on metal. Huh. Yeah, I don't know enough about Unreal, because I would think so when I'm thinking of reflections, I'm thinking of things like ray casting and stuff like that. Things like you can turn off in the environment. Yeah, but like I said, I don't know enough about Unreal to even begin to tell you how you might approach that. But good luck, though. Check each input and subtract and add velocity to obtain total direction. For example, if you hold right down at the same time, the resulting vector will be 1, 1. In this case, you're adding. Right, essentially they will combine, these values will combine depending on which ones are being triggered at the same time. Okay. And of course, that means if the vector ends up being 1, 1, because you're adding horizontal and vertical movement, the player would move fast diagonally if that was diagonally if they were moving horizontally. We can prevent that by if we normalize the velocity, which means the length is set to 1, then multiply it by the desired speed, so it'll no longer have fast diagonal movement. Okay, we can also check whether the player is moving, so we can call player stop on the animated sprite 2D. And here we go. $ shorthand for get node is so the code above, $ animated sprite 2D play is the same as saying get node animated sprite 2D play. Gotcha. And GD script, $ returns a node at the relative path from the current node or returns null. Good to know that. If the node is not found. Since animate 2D is the child of the current node, we can use $2D. So I'm in the player. $ finds this guy first, and then I can do a slash to find this guy after. Yeah, okay. So now we have a movement direction. We can update the player's position. We can, because this is just playing the natural stationary animation once we have movement, which will be none because we have one static image. But I get what it's going for. We can use clamp to prevent it from leaving the screen. Oh, so it will actually stop. Oh, so you don't have to actually put guardrails on your own movement. It'll actually do it for you. That's cool. Giving it a range. Add the following to the bottom of the process function. Make sure it is not indented under the else, because this is like Python and you have to be careful you're indenting. Which I like Python. It's a very powerful language. I like it. I don't like the indenting. I feel like it just leads to spatial problems in your code. And sometimes you accidentally indent something and you've put it under something else without realizing it. I mean, well, you're still putting the guardrails on by putting the screen signs in there, but you don't actually have to check. Like, I feel like in Unity, I'd have to math check the movements, each movement, to make sure it doesn't go beyond the borders. So it's just a little convenience thing this is doing. The delta parameter in the process function refers to the frame length, the amount of time that the previous frame took to complete. Using the value ensures that your movement will will remain consistent even if the frame rate changes. Okay, click play scene and confirm you can move the player around the screen. Okay. I must have done something wrong. Okay. It's... Okay. Well, I've possibly done something wrong here because I can't get it to do anything. Oh, I wonder if this is the area. Whoops. Okay, there it is. Okay, so we're getting it moving. It's a good start. I guess you have to kind of do a little bit more work to get it continuous, because if I just press it, it only does it once per press. All right. Now that the player can move, we need to change the animation frame based on the direction. We can have the walk animation, which the player shows the player walking to the right. Animation should be flipped horizontally using the flip H property left. Then we go up. So we get back to the script, or no? I'm guessing that's how you would. Oh, okay, there it is. All right. So essentially, if there's any velocity on the X or Y, we are going to do the flip V or flip H on the sprite, which again feels like it makes it a lot easier than if you were doing this in Unity. It just kind of takes care of it instead of you having to do a bunch of extra math. Or I mean, that could be in Unity. I just don't know it. Okay, so my hour of this is almost up. I'm trying to decide if I should continue on. I'll make it continue for just a little bit. Then I want to get to the I want to get to doing the game doc. I want to write that up real quick, and I probably will call it a night. Call it a short stream. Uh-oh. Has my avatar stopped? I think it's dead, Jim. Oh, wait a minute, there it is. All right. So weird. All right. Okay. I need to see which ones are which. Can I go back? Yeah, there we go. And I'm sure I just haven't found things in Godot that have made me mad yet. Like I've found in Unity, working in Unity for like kind of more than a year at this point. Like, why are you not finding that? I feel like the function stuff is not fine. This IDE is not finding, but oh well. Okay, so I didn't need a left or I didn't need a. I don't need all four directions. I'll just flip the sprite. Hmm. I don't know. I may get started on the game because well, the basics of the game. I don't know. I'm going back and forth on it. Anyway, we need to keep moving here. Which one are we going to use here? For walking on X, we should use. We'll use left. Why not? So essentially it'll flip the sprite by, depending on the direction we're looking. Not the way it's supposed to work, but it's working. Okay. The next part of this is collisions. I really want to do this one. So we're probably going to continue on with this part. Let's see. And we may call this part of the stream after that. I'm already an hour in. I wanted to be kind of finishing up around this time with the tutorial stuff. Okay, so we want the player to detect when it's being hit by an enemy, but we haven't made any enemies yet. That's okay because we're going to use Godot signal functionality to make it work. Add the following to the top of the script. If you're using Godot script, add it after the extends 2D area 2D. Signal hit. So essentially we can just tell it to activate hit detection. Okay, this defines a custom signal called hit that we can have our player send out when it collides with an enemy. We will use Area 2D to detect a collision. Select the player node and select node tab next to the inspector tab to see the list of signals a player can emit. Okay, there we go. I was wondering where those were at. I was like, there's a lot of them there. Oh, but you can just tell if the mouse is in there, and you can tell, okay. Interesting. Notice our custom hit signal is there as well. Since enemies are going to be rigid body 2 nodes, we want body entered. The signal will be emitted when the player contacts when the body contacts the player. Click connect and connect signal. Entered. It says connect a script, not connect a signal. Oh, connect a signal window appears. Okay, got it. And you can tell it what method to call. Cool. Oops, I hit that by accident. But that'll be the name. Okay, or create the function that is acting directly in the script for you. Oh, right there. The signal will be emitted when the body contacts the player. Note the green icon indicates the signal is connected to the function. This does not mean the function exists. This does not mean the function exists, only that the signal will attempt to connect to the function with that name. So double click to check that the spelling of the function matches exactly. It should, because I put it in there, so I don't have to do it. Okay, so we'll do something. We're gonna make it so when the player's hit, this is being hit, so we're gonna hide it. Then we're gonna do the hit and emit. And we're going to turn off the collision detection after it's hit because we don't want it to keep going off and guessing. And we're going to set the deferred value to or disable value. True. Each time an enemy hits the player, the signal is going to be emitted. We need to disable the player collision so we don't trigger the hit signal more than once, of course. Disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision process. That's why you use set to defer tells Godot to wait to disable the shape until it's safe to do so. Okay, one last piece to add a function. To add a function we can call to reset the player when starting the game. Start just kind of reset. It's a reset. I guess we would call it to restart it. Okay, creating an enemy. So how much time do we have to do all this? Look how much more tutorial this is. Man, this is a good starting point, and I get it. I think I'm good from here on out. I wanted to get to actually doing the collision with an enemy, but I don't think I'm gonna spend all that time on this. But the next part is creating the enemy, then you have to create the scene and the spawn points. The rest of this is just going to have to learn as we go. Because, yeah, we're at 11 o'clock my time as well. And we're already into our second hour of the 48. Let's go ahead and start writing up that game doc. All right. So the game idea is called Spark. Okay. Let's throw a little something on that name. All right, Spark is a Zelda-like dungeon crawler. Where you have I guess you have 3 weapons. Sword, an arrow, or bow and arrow, essentially. And a shockwave. The gameplay loop is when you defeat enemies. They drop sparks that can be collected. Sparks can be used to increase the range and power of attacks. Um, hmm. Just got this. Keep it simple. This is um, just a bare description here, and then we'll break it down a little bit. Any number of available sparks can be applied to an attack to alter it. Example. Sparks can be added to sword attack to do more damage and push or push enemies back. When the player takes damage, they lose previously collected sparks. That way you don't want to get hit. Let's do attacks. Sword. The sword attack is a 180-degree slash in front of the player. Can do that does damage to any enemy it makes contact with, so you can hit multiple enemies at once. Yeah. and pushes them back. Should also say, should say with four-way movement on this. Player presses the left mouse button to do the attack. With a player, let me add this little thing here. Collected by moving over the drop spark. The player wants to use sparks to increase the damage or pushback. Should put up here any number of sparks. Should put the spark count is displayed in the right on the screen. Kind of getting this pretty fast. If I can do this pretty fast, we might jump back to the Godot stuff. But I definitely don't want to spend more than 3 hours tonight on any of this. I want to concentrate on working on the game probably next next stream. I mean, this is working on the game. You've got to plan it out so you're not just scope creeping all over the place and have no game plan. And also, let me add this. Full-way WASD base movement. So we know that we're using the AWS keys, AWSD keys. They're just bugging me that one in the middle. All right. Press the Shift key plus left mouse button. And the let's break that up into 2 sentences. Now you can press the I feel like this is a lot to be doing. Also, let me for is player enters room and fights enemies. I don't know how to spell anymore. Moving. And instead of weapon attack, the number appears over the player, showing the number of sparks to be used in attack. The number is incremented. To increase the pushback amount, we can press, what is it? Control key plus the, and this will probably change. Adjusting the mic here for a second, guys. All right. Just saying, process. Similar to the processor, similar to the that. That's the attack. Push back. Player attacks. The amount for the damage, not attack. The sparks assigned to damage is subtracted from the player's current number of sparks and damage is multiplied by 0.1 times base damage times 0.1 times the number used sparks. C4 back. I gotta take a break. We're going to go ahead and pause the timer here since we're not actually working on the game. Right back. All right, we back. Let's see. We can actually move pretty fast. The rest of these, they're kind of just different versions of the same thing. Why does that always happen? Anyway. All right, so the arrow, or bow and arrow. Bow shoots an arrow that moves across quarter distance of the room. Player uses the right mouse button to do the attack to increase the damage. Shift right instead of doing the attack. Use in the attack, and the number is incremented with it. The distance the arrow travels plus the button damage, but for the travel distance of the arrow. The distance that this is multiplied by what base distance? Shockwave. I think if the player has less sparks when they have assigned to the attack, then no sparks are used in the base values. The attack are used instead. Game ends when players fell through damage reaches 0. Dispose bushes. Enemies back and damages. Pushes any enemies. Back in does damage. This requires at least 1 spark. Or cannot be used. Player presses both left and right in unison together. To do the attack. Where's the cost of we're going to recycle all of this. Should be is incremented. We'll fix that as well. Oh, I hadn't started the clock. I had not started the clock. So let's We'll say spend about 3 minutes. I'll add 3 minutes afterwards. Oops. All right. Oh, anyway. Shift buttons instead of the attack. Attack mode with a 0. If the player wants to increase distance of the push back, press this button. So it's a damage, but for the push back distance. Damage, subtract space, say base push back distance. All right, so that's for our attacks. We're going to essentially have 3 enemies that just do the exact same thing. And so I can push player back. And it causes loss of HP based on base attack damage. And the loss of 1 spark. And see. The bowman does an arrow attack. Really? A quarter of the distance of the room. Should be causes. And causes loss. Oh, okay, let's see. These and these. Constantly move towards these enemies are stationary. Wizards. Do shockwave when player moves within. I did that right. I was going to change it. In range. That do damage. That. Causes a loss of HP. Pushes player back. These enemies are stationary. Okay, I think that covers it. All right. And we still got 9 minutes, or at least 9 minutes minus whatever I'm going to have to adjust for, since I didn't start the timer on time. So let's jump back and see how much of the tutorial we can do. I think I got everything covered here. I don't even remember where the tutorial was. Got so many things open. Okay. All right. Now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex, which is going to be the same for the game jam. Let's see. We have to dodge. The behavior will not be complex. Mobs spawn randomly at the edge of the screen, and close and choose a random direction and move in a straight line. Oops, didn't mean to do that. So click scene, new scene. Then we want your body 2D. And then under that we want animated sprite 2D. And we want a collision shape 2D. And visible on screen notifier 2D. Screen notifier. It's an able and a notifier. Okay, good to know. Don't forget to set the children. Don't forget to set the children so they can be selected like you did with the player scene. So I'm going to make this one not selectable. We had to lock it. I gotta remember how we did that. That's toggles visible. It's not important right now. Well, okay, there we go. Oh, I want to go back to the other scene. Where was my other scene at? Yeah, I'll remember later how to lock it. Just don't want to do it right now. Set the mob to select the mob node to set the gravity scale property on the rigid 2D to 0. Oops, no. Oh, did I say this script? Okay, I'm getting confused here. Anyway, that will prevent the mob from falling downwards. Okay, setting that to 0. In addition, under the collision shaped. Oh wait a minute, collision shape. Okay. under the collision object to the section of the rigid body. Okay. Expand collision. Group and uncheck one inside the mask. And we don't want the defaults. This will ensure that mobs do not collide with each other. Gotcha. I'll set up the animated sprite like you did with the player. I gotta remember everything is. There it is. Okay, you gotta re-click on it, I guess. So we have animations for fly. Well, they're the ones that will come with the tutorial. 2 images for each. Just around 3 images. We'll just grab a bunch of images and it'll just look weird purposely. 3 frames per second. Use the play buttons on the right animation to review your animation. Use the play animation buttons on the right of the animation speed. It ain't playing, but anyway. Like the player images, the model images need to be scaled down. Let's see. Can I clone script for the mobs? Definitely don't want that. Or did I end up closing it? Not meaning to. Or am I just seeing the mob and I'm seeing the script for the player? Anyway. Oh, that was okay. I get it. Plays there. Let's scale you up. As in the players can add the capsule shape 2 for the collision. And again, we'll just do and we can rotate if we need to, but we won't do that here. Okay, add a script to mob. Okay. And it's gonna have us actually play through the different animations. I might just skip this part, or have the different animations selectable, which is good to know. But I don't know if I absolutely need to do that right now. But I get what it's doing. Essentially, you can have a walk, swim, and fly animations. You can just flip between them depending on what's happening. Let's see. We do want to set it up though, so if they leave the screen, the assets are free. So connect the screen exit signal of this. Add this code. So that signal will actually, when it leaves the screen, the mob leaves the screen, it'll just be deleted essentially. Okay, so now that we got this, let's go ahead and create a scene for the game. We'll bring in the player. I'm skipping a lot from the story because I'm not going to do all of this tonight. And the node called main. All right. A node called main. Okay, we're just adding a node. And we're calling it main. Click on the instance button. And let's bring in player. Okay, cool. So does that add you? Just reading here. So I'm probably going to do maybe another 5 minutes of this, and then I'm gonna probably call it, so I don't I'm not waste too much time. Add player. We're gonna add a mob timer. Probably not here. Oh, it's just a timer. We got our 2 timers here. Gonna start us off. Now we're gonna spawn the mob. I'm gonna create a 2D path. The name. Oh, path 2D. Sorry. All right. 2D path. So we should see some new buttons appearing. It's like in the middle one to add. So this we're going to add a starting point, and then we're going to add a path, I'm guessing. To have the point snap to the grid, make sure you use grid snap or smart snap and smart snap both selected. These options can be found to the left of the lock. Left. Okay. Oh, okay. It's good to know. Okay, draw a path in clockwise order. Can I move that? Oops, nope, that's not what I want. I wanted to move it. Oh, I guess it's just gonna, I'm drawing a point from there, so that's fine. This is just to mess around with anyway. They'll be drunk. Add a path follow to the as a child of mob path. This should be mob path. Mob oath. No, mob path. Snow will automatically rotate and follow the path as it moves, so we can use it to select a random position direction along the path. Skipping over a lot of things I'm not trying to do tonight. Yeah, I'm gonna code this up real quick because it requires writing a script to actually get this to work. So I get what it's trying to do here. I'm not sure why it's not actually working. But I get like on the 2D path. You put a randomly position on 2D path. You set a random direction. You set the mob on the path. Then you randomly update which direction they're gonna go in. And you of course apply it to the rotation. And then you give them velocity of where they're gonna move based on direction. And you add them. Not sure what happened. Yeah, so it feels like I'm done something wrong, but I don't know what it is with the timer here. I don't really have time to debug this tonight. Until we see we're gonna go with the game, because I'm going to take the design document and share it with the other team members to see what they think. Because I don't want to waste too much more time on this, and somebody else might end up doing this part. And it's just good to know, though. It's definitely good to know. trying to figure out what I did wrong here, but I'm not going to spend time on it tonight. So, thanks for all the lurkers that stopped by. Much appreciated. We will be continuing this probably later on this week with the adjusted time clock up there for whatever time I missed, I lost there. But thank you so much, Shrill Duck 41, for hanging out with me for a little bit. I will catch you guys later.